Hey, it's Kley. Welcome to another video. Today I wanted to do a look at a schematic review. We're going to be focusing on a bass amp. I've always been curious how the difference between guitar and bass amps, and I think today hopefully should be instructive from a circuit design, how bass guitar approaches distorting and EQing and amplifying the signal in a way that's different than guitar amps. So what we're going to look at today is a schematic of an Ampeg B15. It's probably one of the more famous bass guitar amps ever made. This is an amplifier that was used very frequently in the studio. James Jamerson comes to mind. A lot of those funk bass players that made a lot of those really famous Ampeg bass sounds used this amp, and I think it's a really excellent amp to look at. It's also, I think, going to be pretty digestible for somebody coming from guitar, so I think the transition there should be pretty good. So if you're interested in that, stick around and let's go ahead and dive in. Before we dive into the Ampeg schematic, which I'm really excited to take a look at, I hope you guys get a lot out of, I just want to ask if you guys consider subscribing to the channel. That'll really help me out a lot. I also have a couple links down there to a store where you can buy some nice merchandise to help support the channel, as well as my Patreon page where you can support me directly. It really goes a long ways towards helping me make more videos like this. And to that end, I'd really love to hear from you guys. What is the favorite amp that you've ever played through specifically designed for bass? If you are a guitar player or a bass player, I'd love to hear from you. What is your favorite bass amp? As a guitar player, I don't have a lot of experience specifically with bass amps, and I would love to build or buy an Ampeg like this B15 sometime to see what it really sounds like in person. So please leave that comment down below. I'd love to hear from you guys. Enough of that. Let's go ahead and dive into this Ampeg schematic. Thanks. See you soon. Okay, so looking on the internet, there does appear to be several different Ampeg B15 style schematics. This one is the Ampeg B15N. From what I can tell, that means it has 6L6 GC power tubes, and not all of the B15s have that. But I do think that this schematic is going to be kind of exemplary of what we'll see in terms of the things that I want to point out that I think might be kind of most characteristic of this style amplifier. So let's go ahead and start with the power supply. I think it's always best to go through amplifiers front to back. So let's take a look and see what we can find. Now, first and foremost, we do see, here's our 120 volts coming from the wall. Now, you'll note this is a two-prong power cord. For safety, there should really be a third that gets hard bolted to the chassis, but this is the 1960s. The primary signal goes through a 3-amp fuse into the power switch, into the transformer. This is a pretty solid little setup. There does, I think, appear to be a depth capacitor here, and a polarity switch, which is interesting, how you can go through the fuse but then send the signal here to the other side. It's just kind of a peculiar setup of these old two-prong power cords. But overall, the safety here at least is so far so good. Then we go into this power transformer. It's labeled as PT108. Not the most insane of power transformers. There is a 6.3 volt tap. The red tap is the high voltage, which is center tapped here with the red and white, and then the yellow is our 5 volt winding. So pretty straightforward winds on the power transformer. There is no center tap here, and so you'll notice on the 6.3 volt winding that this is powering all of the heaters. It has a hum contour pot, so a 100 ohm pot that goes from one leg to the other of the 6.3 volt winding, so you can actually vary the resistance just ever so slightly between the two. A nice little trick that you might want to steal from this guy if you are looking to reduce some hum in your amp just a little bit. This hum contour is kind of a neat way to do it, so a nice little trick there. Next, here's our 5AR4 tube rectifier. So using a tube rectifier as opposed to a solid-state diode means you're going to lose a little bit of a voltage drop. Whatever the power transformer voltage, I don't see any voltage readings listed coming off of these two red windings going into pin 4 and 6. There's going to be a little bit of voltage drop there. Yellow is providing our, right here and right here is providing our 5 volt filaments. And then off of pin 8 right here, this is the exit point where you're going to be seeing the high voltage out. So you can see the first line goes right up here, and this goes into the center tap of the power transformer, and that's going to provide high voltage both here to the plate. This is 450 volts, as well as here to this plate. Again, 450 volts DC is a pretty solid amount of voltage, appropriate for 6L6 GC power tubes. Then Next, after we send out this way, we've got a filter cap right here. This looks to be, I think, 30 microfarads at 600 volts. Nice and beefy. Like to see that. Then we've got a 1K 10 watt dropping resistor right here. This is going to power to right here. This is pin 4. So coming on this line, that's going to be 445 volts to our screen. And same here as well. So perfectly stock setup so far for powering a 6L6 GC. Everything looks excellent. Nothing out of the ordinary that you wouldn't see in a guitar amp. So then off of this, we go this way. We've got another filter cap. This looks like 40 microfarads at 500 volts. And then let's take a look. I think that our next stop goes to here. Now, interestingly, the signal splits into parallel. It runs into some 22K dropping resistors at 1 watt, as well as some 40 microfarad filter caps. Now, this line sends here, and I believe this is going to go to our phase inverter tube. So this is going to go right here, and this is going to go to the plate. We've got a plate resistor into the plate. We've got another plate resistor into the plate of this. So this is feeding our 225 volts DC into the plates of our phase inverter tubes. These are 6SL7s phase inverter. So far, so good there. Then our second line is jumping over all these hoops, and that's going this way, and this is basically going to power our entire preamp. So we've got here 220K to this plate. We've got here 470K to this plate, giving us 175 and 165 volts DC on the plates of these 6SL7s on this channel number 2. And the same up here, exact same setup, 220K, 470K, plate, 175, 165. So really these two preamps are exactly identical. I do find it kind of interesting that this last node is supplying voltage to basically 4 triodes, which is a fair number, but nothing inappropriate or problematic here. The current draw here is very low. I think a 12X7 is 1 milliamp per triode, so not a tremendous current draw that's going to create any issues coming off this node. But honestly, so far the power supply looks very straightforward. I don't see that there is a choke installed anywhere. That might be one thing that might have been done in other revisions of the amplifier or something you could experiment with. It would be early on, probably between like right here. Instead of this 1K, you would potentially want to install a choke. That might give you a little bit better noise performance at the cost of it being more expensive. But chokes are awesome, and I love using chokes when possible. So that's the power supply. Pretty straightforward. Let's go to the output section. We've got an 8 ohm speaker, a 8 ohm, I believe it's a 1x50, or I think it was just a head maybe. Somebody correct me if I'm wrong or tell me what the stock speaker cabinet setup was, but does have room for an extension speaker. Now, interesting of note, it appears that, so this is our output transformer, number 214. Now the black is going to ground, that's fine. The center tap is running here, as well as this green, which is going to a 250 ohm 10 watt resistor to the ground of the speaker jack. This is just kind of an interesting setup. Not 100% certain on what's going on here, or why. I'm guessing why they would put this 250 ohm 10 watt resistor here. I'm not sure. This is just puzzling me just a little bit. If I had to think about this, I would imagine that it has something to do with when you would plug in an extension speaker, you still want to maintain the right impedance and resistance. But yeah, I don't know why what exactly this function of this resistor is doing. So would be very curious to know if you guys have any thoughts or any input on why this guy's doing what it's doing. I'd love to hear that. So yeah, if you have any input or any thoughts on that, let me know in the comment section below. I'd be happy to learn. But then going over here back to the primary side, we already talked about this amp has two 6L6 GC power tubes, pretty straightforward. Now, one thing I am looking for to see is these cathodes. The cathodes appear that they go straight to ground. So what that tells me is that next, if I look to the grids, got some grid stopping resistors, that's fine. Okay, right here. So we've got this 270K from right here, this negative 50 volt DC. So that tells me that this is a fixed bias output section in the amplifier. So coming off of this tap right here, here's our diode. And then this is going, we've got a dropping resistor here, it looks like. And then this 100K is going right off of this tap. So it's taking actually the high voltage and giving probably some voltage divider. This 100K and this 56K, I believe, are forming a voltage divider. And then into this diode, and I'm guessing, yep, right here, there's a filter cap and another dropping resistor. All that's going to help get this perfect 50 volts DC. So this is interesting. This power transformer doesn't have a specified tap to provide the negative DC for fixed bias, so they just take it right off of the high tension, the high B plus, and they use this setup with these components right here, this diode, this resistor, this capacitor. So this would be kind of a neat little part of the circuit to copy. Oh, sorry, and this one too. Not this one. A neat little part of the circuit to copy if you need to convert an amp from cathode bias to fixed bias. You don't have a specified tap in your power transformer. You could copy this, and that'll get you roughly 50 volts, negative 50 volts. And I bet one of these resistors you could turn into a variable resistor, maybe this one. Put it into a 50K pot, and I think that would do a nice job of giving you some variable fixed bias. That'd be pretty sweet. 0.02 coupling caps, so far so good, nothing out of the ordinary. One thing I notice as well is we've got this guy. This is a 10K resistor. This is running from right here, this green tap. So this is our negative feedback resistor. So this R40 10K is negative feedback. Whenever I see negative feedback, I always want to make it variable. So you could put a switch in line. You could change this to a pot. That'd be an interesting that would be an interesting way to give some further flexibility to the amp. Maybe put it on a 25K pot in line with maybe like a 1K. So I would change this to a 1K resistor, and then I would put in line a pot as a variable resistor. Tie these two together in here, and then this one here, maybe do it at 25K. That would be pretty interesting. I'd like to see, that's one mod I would probably consider. And then that's going to tuck in here to our phase inverter. Okay, now I'm looking at over here on the right, this is Valve Wizard's explanation of the paraphase phase inverter. We're going to see if we can figure this guy out. What I see first is the signal is coming in right here from both of our channels. We got 270K mixing resistors inputting right here. This is the input from the preamp into the phase inverter. Now out of the plate, we've got a B plus resistor, just like we see here, coupling cap. Now this goes to a mixing resistor or a pot into the grid. This, I think, does the same thing. Comes here. Now this is a fixed resistor and a fixed resistor, but I think that's functionally the same thing that we're saying here. Comes this way through this capacitor into the grid, and then another resistor here to ground. So it's maybe a little bit different than what we're seeing over here. Then on the bottom triode, the cathode, both these cathodes are tied to biased resistors. Now this one has 220, this one has 1K, so they're a little different. This one, the cathode, goes through this 220 ohm resistor and connects directly here to the cathode, which goes through the 1K, and and this bypass cap. So the cathodes are a little bit different, but I think that the route that it's getting there is the same. So I'm going to call this a paraphase phase inverter. I'm more than happy to be proven wrong, but I believe that's what I'm seeing here, and I'm going to go with that. So an interesting type of phase inverter using 2 triodes, so it's not as efficient as the cathodine, but not something I've seen as frequently as the long tail pair. But I think certainly maybe a little bit of a more retro or older design that would certainly contribute to the sound of the amp. So now we can move on and tackle the preamps. There are 2, channel number 1 and channel number 2. Now, from my initial research, I don't know if there is much difference between the 2, but I'm going to take a little closer look now. We're going to start with channel number 1. This has a bright input and a normal input. Now, the only difference between the 2 appears to be that this has 47K of input resistance. This has 100K, which has a bypass cap of 0.005. So what this means is that the very, very high frequencies are basically allowed to bypass over this 100K of resistance. So that's going to the 100K is going to provide some impedance load on the mid and low frequencies, while this capacitor is going to allow them to bypass over, boosting the treble frequencies. Then next, I see a 5.6 meg resistor here to ground. Now, these input resistors to ground that I typically see are located right here before this, what I would call a grid stopping resistor. So I'm wondering, this is either a grid leak resistor, or I also wonder if this is a grid bias setup. This is providing some grid leak bias. I'm a little uncertain, but that I think is what's going on here. That this 5.6 meg it's connected to the grid and is providing some grid leak to help bias this triode. Now there still is 5.6K resistance here on the cathode, 470K on the plate, but I think that's what I'm seeing here. Now this is a 6SL7, so that's why some of these resistance values are a little different than maybe what you'd see with a 12AX7, but still perfectly serviceable. No bypass cap here on this cathode, so that's kind of interesting to note. You could certainly add one. That would certainly probably boost the gain of this amp, unless it maybe interacts with if this is grid leak bias. Certainly more questions here than in other amps I've seen, but let me know in the comment section below what I should be thinking about there. Next, we have a 0.1 UF coupling cap. 0.1 is a lower value. That's definitely going to increase the amount of low-end frequencies. Because this is a bass amp, that's kind of the first indication I'm seeing that it's not looking to trim any low-end frequencies coming right from the pickup after this first gain stage. Then what I see next is an interesting kind of EQ network here. We've got a CR filter. Now on one hand, it's got this ultra low switch. So I believe what this is doing is it's either adding the 1 meg resistor in line with 39K, or it's taking it away. And that's going to shift the bias point of that, the cutoff point of that CR filter. So this is going to trim low-end frequencies and change where that trimming is happening. Definitely an interesting little trick here to give you, when it's just 39K and this switch is straight through, you're going to maybe trim a little bit more of those bass frequencies, but then when you're putting the 1 meg resistor in series, that's going to increase the overall resistance by quite a lot, more than double, and shift that a lot lower. So you're getting, again, more of that raw, straight from the pickup and amplified by 1 gain stage tone. Another 0.01 coupling cap, so a little bit higher now, in probably just helping to interact with some of these other, help keep everything decoupled nicely, and maybe a little bit of tone shaping. Now we have an ultra high switch and a volume control. So here's our first bit of limiting, make sure our volume isn't getting out of hand after this first gain stage. and it has a 500 picofarad bright capacitor that's put on a switch, so it has a bright switch. And the value of this capacitor is something you can really play around a lot with. 500 picofarads, you could go down to 250 or even 100 picofarads. Or you could even remove it entirely, or leave it off of the switch if you so wished. So some nice customization there as well. Now we come to the second gain stage. Plate resistor 220K, 2.2K cathode bias. Again, no bypass cap here. And then amplified. And then in here, this to me looks like a tone stack, and it looks to me like a James tone stack, or these James style are Baxendall, I believe at other times would be referred. I think that in one, the difference between James and Baxendall, one of them is active, meaning has some signal driving it, whereas another one is passive. This looks passive to me. So yeah, a very, very nice little James tone stack here. I think this is probably a pretty critical part of the tone. I have read some notes that in certain variations of the amp, the tone stack was actually here, located here, in between the first and second gain stage, as opposed to after the second gain stage. Right now, this tone stack is basically at the very end, feeding into the phase inverter. And so putting it in the middle here is definitely going to change the tone. Putting it at the end is going to make it more of a pure EQ. Putting it in the middle is going to help it to shift more of the nature and character of the amp with less effect on the final EQ. But this is a nice, the James tone stack is really, really a cool tone stack. It has the capability of being perfectly flat, but it also can boost bass and treble quite a lot. And then you can get, even though the mid-range is fixed, you can still get some mid-range if you use it, some mid-range control if you use it in combination with the volume control. Meaning, if you want to boost mids, you should pull your bass down, pull your treble down, and then boost the volume. And that's going to give you kind of a perceived mid-range increase. Now, taking a look down here, I just want to see if there's any differences that I can spot. A lot of these components look very similar to what I was just reading through. So it's interesting to me that channel 2 is basically a carbon copy clone of channel 1. And from my quick look through the components, it does appear that that's the case. So a really fascinating amp. To be honest with you, it's not a huge harkening away from what you'd find in a guitar amp. There does seem to be less distortion without the cathode bypass caps here and here. It does appear that it has a little bit of a different EQ shaping with both the bright switch and the deep switch, as well as with this James tone stack. So I think, but ultimately, other than that, this really could just as well be a guitar amp. So really my biggest takeaway is, it seems to me like one of the core differences is really on how you are shaping the EQ and how you are handling specifically the low frequencies in your amp, in a bass amp. But as a whole, it's still just an amplifier, and follows a lot of the same design functions you'd see in a guitar amp. So certainly a really cool amp, something I'd love to build someday. If you have any interest in this amp, leave me know in the comment section down below. Have you ever played an Ampeg B15? I'd love to hear from you guys. So leave me a comment down below. I'd love to hear from you. See you again soon. Thanks. Bye.